Hey folks, it's Ozzy here. I work for Go Workplace Training in Melbourne, Victoria. If you're watching this video today, maybe you might be a little bit confused on how you're working out the weight of a concrete pipe. So let's break it down. If you are at one of our courses or another RTO throughout Australia, you may have something that looks a little bit similar to this. This is our homework book for Go Workplace Training in Victoria. If you're at another RTO, ask them for the homework that they should be providing before you attend the course and have a good crack at it before you start. You'll give yourself the best chance of success before you start that course. So today, we're going to be basing our concrete pipe on one of the questions in our homework book. Okay, so there's a 4-step process to finding out how much a concrete pipe weighs. What is that? First of all, we need to find out what our radius is. Then we need to find out what our two volumes are. Then we need to find out what our total volume is. And then we need to find out how much it weighs. So what is a radius? A radius is half a diameter. What is a volume? A volume is the physical size that an object is. For example, this water container holds a capacity of 1.2 litres of water. How much does water weigh? Water weighs exactly 1 kilo per 1 litre, so that mathematics is pretty easy. However, concrete weighs 2,400 kilos per cubic metre, and steel weighs 7,850 kilos per cubic metre. Whereas water is 1,000 litres to a cubic metre, therefore 1,000 litres equals 1,000 kilos, or 1 tonne. Remember that 1,000 kilos equals 1 tonne. So you could say that concrete weighs 2.4 tonnes, steel weighs 7.85 tonnes per cubic metre. Now I just said per cubic metre. Our goal is to find out how many cubic metres are in the concrete pipe behind us. First thing you're going to do when a load comes to site and it doesn't have a consignment note or a weighbridge note or the load's not printed on it, you need to find out how much it weighs before you lift it up. Get your tape measure, get a notebook and start writing down the dimensions. For example, the dimensions for this concrete pipe is it's 1.8 metres in length, it is 2.2 metres on our outside diameter, and it's 1.8 metres from our inside diameter. Now, what is a diameter? A diameter is the distance from one side of a circle all the way to another. In this situation, we have two diameters. We have an outside diameter and an inside diameter. So that is going to give us an outside radius and an inside radius. So using the formula that we have here, let's first work out what our radius is. I encourage you to write all of these calculations out on a piece of paper before you enter them into a calculator, and that way it might help them sink in a little bit more. So first of all, we need to find out what half of our diameter is. Our diameter for our outside is 2.2. So 2.2 divided by 2 equals 1.1. Grab a calculator if you need to. And then our inside diameter is 1.8. So therefore we need to find out what our inside radius is as well. So 1.8 divided by 2 equals 0.9. Now I just did those off the top of my head, but let's do it together on a calculator. Grab your calculator and we're going to go 2.2 divided by 2 equals 1.1. Write the answer up there. And then our inside diameter is 1.8 divided by 2 equals 0.9. Write it up there. That's your outside radius and that's your inside radius. We've just finished part 1. Let's move on to part 2. So the second part of our formula, we need to square the radius, multiply it by pi, and then multiply it by length. But what does that mean? When we square a number, we multiply it by itself. So for 1.1, you would multiply it 1.1 by 1.1. So let's write that out. 1.1 times 1.1. Don't get confused by the 2 being written next to the radius. Okay? It is not 1.1 times 2 because that will just end up giving us 2.2 again. We don't want to do that. We want to multiply the number, whatever the number is, by itself. So if it was 16 and we square the number 16, it would be 16 times 16, which would not give you 32. It would give you some crazy number. Anyhow, back to the whiteboard. That's the first part of working out our volume. So radius times radius, 1.1 times 1.1 times pi. That symbol is pi. Pi is equal to 3.142. Let's write that up here. And then we need to multiply that by our length. What is our length? Our length is 1.8 meters. Equals. Before we hit the calculator, let's write the same thing out for our other dimension. Our other dimension is 0.9 meters, radius, 0.9 times 0.9 times pi, 3.142, times length, 1.8, equals. And now we're going to enter all of that into the calculator. Let's go. 1.1 times 1.1 times 3.142 times 1.8. If you're lost at this point, hit rewind and watch it again. And that gives us 6.843276. I'm going to wipe off the rest of those numbers and just say it's 6.843. Now it's important that you don't round any of the numbers at this stage. We're going to do rounding at the very end of this calculation. Now let's work out what our inside volume is. Let's do the same thing again for this part. 0.9 times 0.9 times 3.142, which is pi, times our length, which is 1.8, gives us 4.581036. Just take the first three numbers after your decimal point. So 4.581. Congratulations! We've just finished the second part of the formula. Part 3. Now we want to find out what the difference is between these two numbers. So if we base this calculation on a solid concrete cylinder with a radius of 1.1 meters, then we would have a total of 6.843 cubic meters of concrete. However, we've got all this air in the middle. Now I don't know how much air weighs, but it's not much. So we're going to try and wipe that out. So what we want to do is take our two different radiuses, get our two different volumes, and find out what the difference is. The difference between these two numbers is going to give us a total of how much concrete is actually in the pipe and not what's in the middle. So this part's pretty easy. You just want to take your outside volume and subtract your inside volume away from that. So what we want to do is get our bigger number, enter that into the calculator, 6.843, and then we're going to subtract or take away 4.581, and it's going to equal 2.262. So I'm going to put the little take symbol there. It's going to equal 2.262. Now what is that number? Is that tons? Is it kilos? Is it something else? It's not weight. That is volume. That is 2.262 cubic meters, or meters 3, of what material is this? It's concrete. How much does concrete weigh per cubic meter? It weighs 2.4 tons per cubic meters, which is also the equivalent of 2,400 kilos per cubic meter. So we've just done part 3 of our formula. Now we're going to do part 4. It looks confusing, but this is the easiest part of our entire formula. So what we want to do is we want to take that number, which is our volume measured in cubic meters, we want to multiply that by our mass, and that's going to give us our total weight. So mass is how much a physical object weighs per whatever size it is. So what we want to do now is we want to take that number, 2.262 cubic meters, and we want to multiply that by our mass. Our mass for concrete is 2,400 kilos per cubic meters. So 2.262 times 2.4 equals 5.428. Now what is that number? That is your weight. That is tons. Or if you multiplied that by 2,400, your answer would be 5,428 kilos. But because we multiplied it by 2.4, we're multiplying it by tons. So the answer is going to be in tons. There is no right or wrong way about doing this. You can multiply it by 2,400 kg, and that's going to give you 5,428 kg. But if you multiply it by 2.4, it'll give you your answer in tonnes, which would be 5.428. Now, our last bit. I said don't round anything right up until the very end. This is where we round our numbers. So you're not going to go to site and tell the crane operator that you've calculated the weight of the load and the load weighs 5,428 kilos, are you? No. You're going to round it up to the nearest place. So you might go to the crane operator and say, it weighs approximately 5.5 tonne. You might even go the next step further and you could say, it weighs 6 tonne. And the reason that you round these numbers up is so that you find slings that are capable of carrying the load that is heavier than it actually is. I hope you've enjoyed this video. I hope you've learnt something. I hope it's made sense. And if it doesn't, please leave a comment in the comment section below, leave a like, subscribe for some future content, and I'll see you in the classroom.